Hi everyone, I'm Dick McCarthy. Today I wanted to go over phenol destruction. So every so often in wastewater treatment, we come across a customer or prospect that has phenols in their effluent. This is a major problem. Cities don't want to have it. Your customer, most of the time that'll have phenols, is a central wastewater treater, central waste treater. It could also be somebody working in antiseptics, disinfectants, wood stains, etc. So to handle that, really, permanganates are a great option. Basic coagulation and flocculation won't really do it. The first step is finding out, what is their phenol limit and what is their actual. The next step is getting a sample of permanganate. I highly recommend, for safety purposes, you get a small amount of dry that you can make down into a weak solution. A normal 20% to 40% sodium permanganate is not really something you want to be messing around with. In a lab setting, even in the field, even worse. So for our purposes today, I made a 5 ppm phenol standard. For your calculations, if you're following along, just replace this number with whatever their phenol is in their effluent that you want to destroy. The theoretical dosage of permanganate to phenol is around 6 to 8 to 1. That's really in a jar with little to no solids. For our jar testing purposes, the permanganate we made down is a 0.1% solution. That's 1 gram into 1,000 mils. That gives us something that's pretty weak. We can easily neutralize it with a vinegar hydrogen peroxide mix, and we don't have to worry about it oxidizing any materials or starting a fire. So for our calculation and jar testing, for our purposes, we're going to use a 200 ml sample jar today. So I need to know that if I have 5 ppm of phenol and the theoretical is 6 to 8 ppm of permanganate, that'll give us 30. We cross multiply 30 times 200 divided by 1,000,000 for that ppm. That'll give us 0.006 mils. Now we need to divide that by our dilution factor. Going from a percentage to a decimal, we'll move the decimal over 2 places. So 0.006 divided by 0.001 will give us 6 mils. So we're going to put 6 mils of our 0.1% solution of permanganate to neutralize 5 ppm of phenol. And we're going to do a couple other dosages because I want to bracket it. I want to get a low and a high and narrow it down. And we'll show you what that jar testing looks like. For safety purposes, go ahead and make down a hydrogen peroxide vinegar mix 1-to-1 solution. And you can use that for any spills that happen. It'll neutralize the permanganate. Store-bought is fine. You don't need anything high grade or high strength. For the test today, we have made down a 5 ppm phenol standard to test. We have our safety gear to include glasses, gloves, and coat. Sodium permanganate is not something you want to get on you. We also have our Chemetz K8012 test kit, and we've made down a 1 gram per liter permanganate standard. This standard is about a 0.1% standard, and it is much better to use than a 20 or 40% industry standard that you would actually dose at a facility due to the safety hazards of spilling sodium permanganate. Here we have all 3 samples, 200 mils each, ready to go. First 2 jars are dosed. And now I'm just taking my syringe, aiming at the side of the vortex, and quickly releasing all of the permanganate into the 3rd jar. After 15 minutes of mixing, we can see 3 different colors on the 6, 8, and 10 part per million samples. The sample on the far left has no pink left, so most likely all of the permanganate was used up, and it's either the correct dosage or underdosed. And we see the far one on the right has the 10 part per million sample has quite a bit of pink left, so it's probably overdosed. So now we're going to use the Chemetz test and see where we're at. All right, so we're going to pour in 25 mils. And then we are going to take this ampule, stir it in, make sure everything at the tip, all the orange dissolves, break it off, invert it, and test it. After 1 minute has passed, you're going to take your ampule and place it
along the colorimetric chart where you think the color matches. Ours is probably around 0 to 0.5. In between tests, make sure you're rinsing out your vial with DI water and letting it dry before your second test. On our second sample, you can see there really is no color at all left in it, even though the jar was pretty orange after we ran the test. It appears that there is most likely 0 parts per million of phenol left in the sample. And now we're going to do our third sample. Even though it is more product and the last two look like there is 0 phenol left, we'll still run this. I'm stirring, letting all that orange on the end of the ampule dissolve. As you can see, the dark orange is gone. We're going to break the ampule, let it fill, invert it a couple times, making sure not to touch the tip because it may be sharp. You can see most of that color is gone. And we're gonna wait 60 seconds and then test it. Here are the 3 samples once they're all done. The bottom one was the first, and you can tell there's a little bit of red hue to it. So we're gonna put it in our low level phenol kit that came with the chem kit. And essentially you slide it into the top, turn it over, and then based on the color, you can see there is a little bit of color there, and we would mark it maybe around 0.4 ppm of phenol in the first sample that had 6 ppm of sodium permanganate. It's obviously really important to properly dispose of lab waste. So here we have some permanganate left in our syringe. I don't want to throw this right in the garbage because it is an oxidizer. So we are going to stick it in the 1-to-1 ratio hydrogen peroxide and vinegar solution that we made. And I'm going to leave it in this syringe, let it mix around until all that color is out of it. And I'm going to eject it, inspect for color again, and now I can throw out my syringe in our solid waste lab container. It's also very important to dispose of the liquid waste properly, so I've opened the top of our liquid waste canister, unsealed the can inside, and now I'm going to dump out the liquid and seal everything back up. So we did our testing on distilled water dosed with phenol, and now we're going to look at actual waste from a central water treater. It has about 2.5 ppm of phenol in it, and we're going to test out that 8 ppm dosage, and I'm also going to do a 16 ppm dosage to double it, and we'll try and bracket it because it has solids in it. We're expecting we're going to need more because that permanganate is going to go after more than just phenol. As you can see, this is the higher dosage. It is turning pink, so that's a good sign. We'll see if it stays pink or if it gets all used up. All right, you can see after 15 minutes we did get a color change. I did add a little bit of a flocculant. It's an anionic flocculant, which the customer does use. And this was just so that I could get some separation between the solids and the liquid when I pour my sample off into the 25 ml vial. For the chemits test, I don't want it filled with solids. So I got the results back on our higher dose of permanganate and our lower dose. And as you can see, the higher dose has none in it, and the lower dose still has about 1 ppm in it. So if we were testing this for a real customer, we would just keep bracketing it lower and lower and a little bit higher until we found the perfect dosage for our customer to use in real time.
Thank you very much for your time today. I hope you learned something. If you have any questions at all, please feel free to reach out to myself via email or Christian Anderson, our industry marketing manager that covers permanganates. Thank you and have a great day.